Okay, this is a continuation of the last video and got cut off. There may be some type of possessed demon voice happening at the end of that. I don't know what's going on there. We'll see how it turns out. Identify domain and range. I already did this one, but the recording evidently had stopped. I'm going to just sketch this thing. So I know this is the square root graph. Looks like that, starting at 0, 0. I'm going to shift to the left 3, because that's what makes this 0. And then down 4. And it's not called the vertex, but it's kind of like the vertex. You'd shift a parabola the same way. So that gives me the domain. Domain is left to right, all the x's. So I know my smallest value is -3 to infinity. You can write it that way. This is the same notation. X is greater than or equal to -3. And then the y value, the smallest value is -4. And the biggest value is infinity. Set builder would be like this. Write a polynomial function of least degree with integral coefficients, least degree. And it says these are given zeros. So in other words, I know what the factors are. So I know my zeros are 5, 3, and 1. So I know that if I factored this, that any one of these would make this 0. Okay, if they would have given us 0 as a 0, then one of my solutions would have been x, or one of my factors would have been x. So essentially all you need to do is multiply these out. Multiply the first two, and then multiply, didn't distribute the x minus 1 and combine your like terms. It says integral coefficients. You could have a 7 here if you wanted to. The reason that they put that there is if one of these is some kind of a fraction, you got to make sure there's no fractions at the end. Sketch the graph of each function, state the domain and range. This is another parabola, so you're going to find the vertex, and then the domain will always be all reals on the parabola. It's because it's going to go left to right forever. But the range, you need to go to the vertex, and it's going to be from the vertex down or the vertex up. In this case, it's going to be the vertex up. All right, let's look at this one. This is the famous rational expression. So let's just go through our checklist here. What do we have? Well, we know there's a vertical asymptote at 2. So I'm going to make one. And because I know that I can't use 2. Everything's already factored. What else do I know? I know that one of the zeros of the function is 3, because negative x plus 3 equals 0. If the numerator is 0, the whole thing is 0. So I have the point 3, 0 on my graph. So I'm going to put that on here. And then I also have the degree of the numerator and the degree of the denominator is the same. So that means there's 3 cases. One is if the numerator is greater than the denominator, that means there's no horizontal asymptote. If they're equal, there's a horizontal asymptote at the ratio of the leading coefficient. So y equals -1 over 1. So I know I have an asymptote right there. And at this point, you can start picking some points to plot. I guess I can try to find the y-intercept real quick. The y-intercept is when x is 0. So if you cover up x, you get -3/2. So the y-intercept is at -1/2. So it's right here. At this point, you can plot points, make a table. I'm going to use the calculator real quick. Make sure that if you're using your calculator, you still know how basically to talk about all the different characteristics, because your calculator is not always the most helpful for showing some of those things. So my sketch is coming in here. Put in something wrong. That's why you go do that ahead of time. There we go. So I have my information there because when I put in the wrong number, I get a graph, but it's not the right one. So now I know this is right. I see my 0 here. I see my vertical asymptote. So I know I can just kind of make a sketch, making sure that I go through that point. and I approach those but don't touch them. Horizontal asymptote can be crossed. If you go to your table and you look, as we get really, really, really small with our x's, we get closer and closer to it. Sometimes we cross it, often we don't. Okay, keep going here. Excluded values. This is another rational expression. Always you want to factor before you start talking about asymptotes and exclusions and all that kind of stuff. So here's what I know. Excluded values, I cannot use 0 and -3. But I can cross out that -3. So that at x equals -3, there's going to be a hole. It's still excluded, but there's a hole. You won't be able to see it on your calculator. And x equals 0 is a vertical asymptote. So two different kinds of excluded values that go with that. Quadratic in standard form given the vertex. And if you need more practice on these quadratics, there's a bunch more videos back on the rest of the page, or on the rest of my YouTube site. But put in the vertex, y equals a, x plus 2 squared plus 5. So I'm trying to find a, I plug in the vertex, I'm putting my point in, they give me a point, -4, -3. I'm going to put my point in, and I'm going to solve for a. You're always trying to solve for a. If you know the vertex, you plug it in. So this says write the equation in vertex, if the equation in standard form here. So again, find the vertex, -b over 2a. Once you know the vertex, you plug it into the vertex form. And in this case, I already know what a is, so I can be done with that. That's going to be it for this video.